So in this video, we're going to process our elevation, soil, and land use data for input into SWAT+. So I'm going to start by uploading my watershed boundary. I'll click on this data source manager up in the top left. And then in the manager, I'll navigate to the folder where I've stored my watershed data. Then I'll select the file, and I'll click on this button that adds it to the map. And it appears here in the layers pane. So I'll close out of this data browser. So this layer includes all the watershed boundaries for all the HUC-12 watersheds in the Mid-Atlantic region. We need to pick out the one HUC-12 boundary for our watershed, the Conewago Creek boundary. We'll do that by right-clicking on this layer name, opening attribute table. Then we'll scroll over to the column titled HUC-12, double-click on the title to sort it in order, and then we'll scroll down until we get to the HUC-12 for Conewago Creek. Then we'll click on the row name for Conewago. That selects that watershed. And if I close out of the attributes table, you can see that on the map, the Conewago Creek watershed is now highlighted in yellow. So we'll turn that into its own separate layer by right-clicking on this layer name again, going to Export, and going to Save Selected Features As. We'll save it as an Esri shapefile. I'll use these three dots to give it a location to save to. I'm going to save it in a folder for this data processing and in a subfolder for watershed boundary files. And I'll just give it a name that tells me it's a boundary. Then I'll click OK, and it adds the boundary file to the map. If I remove the old layer, I can see now that my new layer has only the Conewago Creek in it. So now I'm going to project this watershed boundary to a projected coordinate system. I'll do that by right-clicking, going to Export, and Save Features As. And now we're just going to save it to a new layer with a different coordinate system. So I want it to be a shapefile. I'm going to give it a path to save to. I'll name this file just something that tells me it's a projected layer. And then I'll click on this little globe icon to choose my coordinate reference system. So I can use this search bar to type the coordinate reference system I want. In my case, it's in my recently used. I'm looking for UTM zone 18N because Conewago Creek is in UTM zone 18. I'll click OK. And then I'll click OK to create this layer. And now I have a new layer, the projected watershed boundary. Next, I'm going to add a buffer to the outside of this watershed boundary because the watershed boundary SWAT delineates won't necessarily match up with this one. So we want to add a little margin of error to make up for any discrepancy there might be. So I'll do that by going to the vector menu up top, geoprocessing tools, and buffer. My input layer should be my projected watershed boundary. I'm going to set my distance, which is the width of the buffer, to 500 meters, which is really generous. Then I'll scroll down and I'll give it a file. I'll give it a path where it can save the file. And I'll give it a title that tells me it's a buffered layer. And then I'll run the process. And if I move my plain projected watershed boundary on top of the buffered one, you can see that the buffering process has added this ring around the outside of the watershed. So now I'm going to remove all of my layers except for that buffered watershed boundary because I won't need them anymore. And now I'm going to move on to processing the DEM, the elevation data. I'll start by downloading that data into QGIS. I'll just navigate to the place where I've saved it, click on the layer, and click on this Add button. Now, first I need to project this DEM to the same coordinate reference system I used for the boundary. So same process, I'll right-click on the layer, go to Export, Save As. I'll give it a location to save to. I've created a separate folder for DEM files, and I'll give it a label that tells me it's projected. Then I'll choose the same coordinate reference system, UTM zone 18N, and I'll hit OK. It takes a little longer because the DEM is a bigger file. And then it adds this projected DEM to the map. My next step is to clip this projected DEM down to the watershed boundary. That gives the SWAT Plus setup process less data to chew through, and so it'll take less time. So to clip, I'm going to go over to the processing toolbox and just search clip. And I'm looking for this tool, clip raster by mask layer. My input layer is the layer I'm looking to clip, so that's my projected DEM. My mask layer is the outline I'm using to clip it, so that'll be my watershed, my buffered watershed boundary. And then I'll give it a place to save. I'll give it a file name that tells me it's clipped. And then I'll run the process. So if I remove all of my other DEM layers, I can see that I now have a DEM that's clipped to exactly the watershed boundary. So that's it for DEM processing. I'm going to remove those layers from my map. And I'll move on to land use. So I'll start by uploading my land use data layer. Again, I'll open this data source manager. I'll navigate to the folder, and I'll choose the TIFF file where my land use is saved. If I add it to the map, you can see this raster appear. And once again, we need to project this to the new coordinate system. So I'll right-click, export, save as. I'll give it a location to save to. I have a separate folder for land use and land cover files. And I'll give it a name that tells me it's a projected layer. Then I'll go to this little globe icon to choose my coordinate reference system. And I'll change it to my projected coordinate reference system, UTM zone 18. I'll hit OK. And it's projected the land use layer. Next, I need to clip my land use layer. So I'll once again use this clip raster by mask. This time I want my input layer to be my projected land use. My mask layer is once again my buffered watershed boundary. Scroll down, that checkbox is selected, and I'll give it a place to save. And then I'll run. And if I remove my other land use layers, I can see that I have this watershed-shaped land use raster. And that's it for land use. I'll remove those layers. And then I'll move on to soil. So I have 3 separate soil files. I have one for Dauphin County, one for Lancaster County, and one for Lebanon County, because my watershed is right on the boundary. So I'll upload each of those files. They're all shape files. Then I'll close out of the browser. The first thing I want to do is merge these soil shape files into one single shapefile. So I'll search merge in the processing toolbox and select merge vector layers. I'll go to these 3 dots to choose my input layers, and I'll select all 3 of my soil shape files and click OK. That selects 3 inputs. Then I'll give it a file path to save to. And I'll give it a file name that tells me it's a merged file. And I'll run it. Great, so now I have a single soil file that covers the whole watershed area. Next, I want to project that to my projected coordinate system. So I'll right-click, export, save features as. I'll give it a place to save. And then I'll go to this globe icon to choose my projected coordinate reference system. And I'll hit OK. And then I'll hit OK. And now I've added this new layer, the projected layer. So the next thing I need to do is convert this shapefile to a raster. And to do that, I'm going to use a tool called rasterize. And if I search for that, I can click on it. I can get it out of the processing toolbox. So what rasterize requires is an input layer, which is going to be my merged projected soil data. But it also needs me to give it a particular field, an attribute of that input layer that it can use to populate the raster with values. At the moment, the value we need is not here. So we're going to need to create a field that this tool can use to create a raster. So I'll close out of this tool, and I'll go to my merged projected soil file and open the attributes table. So the attribute we're going to use to create a raster is mu_key. mu_key is an ID number that identifies the soil type. So the reason we can't use this to create a raster right now is that QGIS is seeing this not as a number, but as a string. We need to convert it to a number so that QGIS can use it to make a raster. So we do that by going to this field calculator, this abacus button. We're going to create a new field. I'm going to name it mu_key2. And I'm going to use this expression box to tell it how to calculate that new field. I'm going to use the function toInt, which converts to an integer. And the argument I'm going to give it is mu_key. So this expression is going to take all the values in the mu_key field and convert them to integers, and then use that to populate this new field. So I'll hit OK. And now my attributes table has this new mu_key2 field. I'll go to Save Edits to make that field permanent. And then I'll close out of this editor window. Now I can go back to my rasterize tool. My input layer is my merged projected soil data. I can select mu_key2 as my field to use for burn-in value. I want to make sure this next field is blank. Otherwise, it'll just burn 0 as the value of all pixels in the raster, which will defeat the point of creating mu_key2. Then I need to set my size units for the raster pixels. I'm going to use georeferenced units. That means that the next two fields are the width and height of each raster pixel in meters. I'm going to set this as 30 meters. Then I'll scroll down. And I'll give it a file to save to. I'm using a file name that tells me it's rasterized. And I'll run the process. So now if I use this little down arrow to expand the information about my raster layer, I can see that this raster has values, has non-zero values, which is a good sign that this process worked. So the final thing I need to do for my soil data is clip it down to the size of the watershed. So once again, I'll go to the processing toolbox and search for clip, and I'll go to clip raster by mask layer. My input layer is my new soil raster. My mask layer is my buffered watershed boundary. I'll scroll all the way down and give it a place to save. Making a note that this is my clipped file. And then I'll run it. Let's just check to make sure that worked. I'll remove all of these other raster layers, other soil layers. And I end up with this watershed shaped soil file. And that's pretty much it. We've now processed DEMs, land use, and soil data, and we're ready to upload into SWAT+. Thanks for listening.